Hello, everybody, and welcome. I wanted to just do a little introduction to paper circuits. Paper circuits are a really interesting way to get into electronics, especially if you are intimidated by the world of physical computing and things lighting up. And so I wanted to share, since, when you begin a project and you're working on paper prototyping and cardboard prototyping, using whatever materials you have accessible, paper circuits are a really inexpensive way to add some lights, add some sound, add some electronics into your prototypes. So without further ado, I wanted to just introduce the tools. I will share, a tentative parts list as well as links to some of these templates if you're interested in recreating this at home. But the main ingredients of paper circuits is copper tape or any sort of conductive tape that you can find, which has usually a sticky side and a conductive side on the top. It comes in different thicknesses. This is a 1/4 inch thick, and it works really well for a lot of different applications. And then and this is your conductor. So this is what you're gonna use to conduct electricity throughout your circuit. And then as an output, we're gonna use just a little LED. LED stands for light emitting diodes. And this is a diode that when current goes through it, lights up. The interesting thing to note about LEDs, they also come in all sorts of different shapes and sizes. This is a pretty standard, I believe, 5mm LED, which is the diameter of the top. LEDs are polarized, meaning some electronic components have a specific way in which they want to be plugged into a circuit, meaning that one of the sides usually likes to be hooked up to power and the other side needs to be hooked up to ground. And so you can visually tell that usually about components because they will have some sort of markings or visual way in which they are constructed that tells you that the sides are different. And so if you notice with this LED, the difference is that one leg is shorter than the other. And so the shorter leg is the one that wants to go towards the negative side of your power supply or your circuit or ground, and the longer leg is the one that you want to attach to power. The reason why I'm mentioning this is because sometimes when you prototype a paper circuit, you forget and things don't light up or don't work. And so one first thing to troubleshoot or check is if you actually had your component situated in the correct orientation. And then the last thing that we need is some sort of low voltage power source. And in this case, I'm going to use a coin cell battery, which is 3 volts, which is pretty much what most LEDs are happy with. Most LEDs are around 2 to 3 volts. So it will shine a little bright because of this power supply. And then some kind of paper. For this specific first circuit, what I like to do is use these templates that you can actually download online, or you can just take a regular piece of paper and kind of create a similar design. And once you've kind of mastered this initial design, then you can move on to making all sorts of different things, which will look like, for example, you can make flashlights, you can make much more intricate patterns that are actually part of the design. You could make pop-up cards and light-up cards. And as I said, you can add then, a circuit with, some sort of output that actually either emit light or sound or moves to pretty much any cardboard prototype that you're building. So I like these templates because visually it kind of tells you where everything goes. Before we place these two components, we can start getting familiar with the copper tape and actually start to cut some pieces to trace these lines. I have a couple of tips from doing this for quite a while, and that came from experience and troubleshooting and frustration. Conductive tape is pretty conductive, meaning that it works really well, but the underside, although when you peel it, you'll see that the underside actually has copper at the bottom, is covered with the sticky layer, which sometimes makes it a lot less conductive. So there's a couple of tricks that you might want to keep in mind. So very much like if you were using any sort of tape, you want to, in this case, trace the circuit that you have here. Instead of making corners, which is a temptation, and conductivity should still flow through, like electricity should still flow through, because of the backing of sticky material, sometimes it doesn't actually make a good connection. So what I like to do is make sure that like my traces are actually smoothed as much as I can and don't have a lot of creases. And then I like to, instead of making corners, I like to go over the corner with another piece to try and make as strong of a connection as I possibly can. And I like to cut them in smaller segments. A little bit too long. And so since we talked about, components being polarized, you'll see it in this template. They very nicely kind of mark it. And it's because when your battery goes on here, there will be, a face, which is in this case, the negative side of the battery facing down. So this is actually the ground side. So you do want your LED to be facing the correct direction. So now that I got to the LED, I want to leave a space for this component, because if we continue to just make a closed loop, then you'll have what's called a short circuit, which is a circuit that doesn't have a load, that just has power coming into it, that's able to flow around because of the conductive material, but there is actually no component to consume it. So the negative side we mentioned is the shorter side. For paper circuits, it depends on how you could clip the leads, or you could just bend them. Sometimes you can with a tool like a little tweezer. You can make a little loop on the sides if you wanted to, for example, use it in wearables and actually sew it together. Another thing that people tend to do is to put the lead under the copper tape. And because, again, of the sticky surface, sometimes that does not actually work. So what I recommend doing is sandwiching it between different layers of copper tape. And so I'm going to take one piece to put on this side. Too short, but it doesn't matter. Try and extend it a little bit over. Basically, the cleaner your connections and your joints can be, the more reliable your circuit is going to be. So now, one note is when we cut the leads or when we bent them, it's harder to tell which one is the positive and which one is the negative side. Sometimes LEDs will actually also have another way to tell, which is that the enclosure at the top on usually the negative side will have a little slit cut out of it. So if you accidentally shorten the leads and you forget which way you need to insert it in a circuit, you can usually look at the top and still make out the orientation of this component. And so what I'd like to do is sit it on top and then take some other pieces of copper tape to kind of sandwich these legs in place. And personally, I found that that makes for a slightly more reliable connection. And of course, now that I said that, when we finish the circuit, I bet it won't actually work, just because of the power of demos. And then we have one more piece of circuit. Again, this is like just an arbitrary design. What this is showing you is that circuits are, you know, they are loops. They're closed loops once you connect the power supply, that are made up of two main components. Power source, in this case, our tiny battery, and a load, something that's going to use that power. And all of this is connected together through some form of conductive material. And so now I'm going to okay, and I'm gonna make sure everything is nice and flush. And then moment of truth, batteries are polarized, right? So they're marked with a plus sign or a minus sign depending. And so this is the positive side. So this is the side that I want to put on here. And then this is showing you as kind of like this gap is acting like a switch. And so if you turn it around and close the circuit, right? This is your fold is acting like a switch. And so this is, you know, a simple circuit, but that, you know, actually does allow you to do all sorts of different things, because if, you know, depending on your power source, especially if it's just like a 3-volt coin cell battery, there's other electronic components, other outputs that work at the same voltage that you could swap out for your LED. So for example, you know, you could be introducing a speaker, right? Or a little piezo buzzer, something that makes some sound. Again, this is also polarized and it's indicated by 2 different color wires. Red is for power and black is for ground. So if I try and connect them to the 2 different side of the circuit and I close the circuit, light and sound at the same time. There's also some interesting, you know, 3-volt motors. This is a little buzzer. It's just a tiny little vibrating motor. And so same thing, although this one is like harder for me to hold in position and not cover it with my hand. So let's see, these are tiny little wires. And so if I wish I had an extra hand. I can have it work. Yeah. And so you see that now, again, you get, you know, this draws too much current. And so my LED is not happy, but you could imagine just taking that out and just using basically other outputs. You don't have to just use light. And now you see that my motor is vibrating. So there's actually quite a lot that you can do with these circuits. And as I said, you don't have to stick to this form factor. There is this link, makerspaces.com/paper dash circuits that has a lot of really cool other circuits. For example, a parallel circuit allows you with just one battery to use multiple LEDs. And so this is a pattern to do that. And then they have some really cool example where if you had 3 different color LEDs, you know, you could actually create a little traffic light. You could use, you know, a piece of conductive material to just close whichever path you want to turn on the green or the yellow or the red light. These are all printables. And this is, for example, a doorbell. So very much like the circuit that we just built that used, you know, a little buzzer instead of the LED. This is something that you could do. And this is giving you the idea that you could start shaping your circuits, and so all this is tape, however you actually want. And so this was the basic circuit, also just shaped like a lamp. And to make a switch, all you need to do is just leave a gap in your circuit and just use a piece of conductive material. Could be a pin, it could be safety pins, it could be a paper clip, or it could be, you know, another piece of tape that you can use so that you can decide when you turn things on and off. And if you don't want to do an entire paper circuit using copper tape, there's also a super simple way to just add, for example, a light to your electronic project. This is called an LED throwy, which is, as the word says, is an LED that you can throw. And it's, you know, again, talking about the polarization of this component. If you directly place your, you know, positive end of your LED to the positive side of your battery and the negative to the negative, and you kind of sandwich it together, you have a little light. You can use tape if you want to, just regular Scotch tape to tape it around. And then, or if you don't want to use tape, one thing that you can use is magnets. Magnets will stick to this battery, and you can use magnets sometimes to stick the connection together in a non-permanent way. And then you can actually use this as a fridge magnet, or as you could make an entire picture with a bunch of different LED magnets, and you can create whatever design. I don't recommend throwing them, but you know, if they do come across a magnetic surface, they will stick. But that's also another like quick way if you just want to put some, for example, if you just want to put some light up eyes in your creations, or some night lights in a cityscape or in a model of a city, or things like that. This is just a super basic. This is the kind of the most and scrappiest circuit that you could ever make. That's just a power source and your load. Another cool thing that you can make when you make LED throwies is that you can actually start to make some, if you're prototyping wearables or things that go on your body, you can use this to add some lights. And using magnets, you can easily then attach these to like a paper clip, or you can a hair clip rather, or you can, for example, use this to add to your clothes, to add some light to your clothes using the magnets, right? And so you can add some light up pins, or if you have interesting containers, recycled materials. You could use, I'm going to shut my light off so that you can see it better. You know, you can make some little light up flashlights, or some, as I said, add some little lights to your creation. Thank you so much for watching this, and let us know if you have any questions on paper prototyping and on paper circuits. Thank you.